So what we're looking at here is sleep researchers have looked at early birds versus night owls, and they are looking at the number of dreams recalled per week. Um, so one hypothesis that they want to test, written in the question, is that they basically believe that night owls get or they recall more dreams than early birds do. So state two other pairs of hypotheses that could also test that same idea. Okay, so once again, the idea that night owls they recall more dreams than early birds. Okay, so another way to write this pair of hypothesis would be that you would say the mean of night owls is equal to the mean of early birds versus mean of night owls is greater than the mean of early birds. So that's another way to write the same pair of hypotheses. Okay, both of them are basically saying that night owls recall more dreams. Another way to do this, you could say the mean of night owls minus the mean of early birds is equal to 0 versus the mean of night owls minus the mean of early birds is greater than 0. Once again, in all three of these cases, so the one that they gave us, this one right here, and this one right here, in all three cases, we are checking that night owls recall more dreams than early birds, but we can write that alternate hypothesis in three different ways. Now, use the data provided to carry out a test of hypothesis about the mean number of dreams called per week. Okay, so this is a means question. This is not a matched pair scenario, though. We have two separate groups from each other, okay? We have early birds, we have night owls. They are not paired up at all. One thing to look at when comparing these, though, they gave us a lot of information to throw us off here, okay? So first off, this is a means question, okay? So all this proportion stuff means nothing. Also, because it's a means question, the median doesn't mean anything either. So we're not going to use any of that at all. Other important information is that I think it said somewhere in the question that they got like 100 people. Yep, 100 people of each of the two types was selected at random and asked to record their dreams for 1 week. So let us get started on part B, which part B is the full-blown hypothesis test, okay? So 1, I like to do this. The mean of night owls is the same as early birds. That's what's assumed to be true. The alternate, the mean of night owls is greater than the mean of early birds. So the average night owl remembers more dreams than the average early bird. Okay, so there is our null hypothesis. There is our alternate hypothesis. There's our parameter of interest. Okay, for assumptions and conditions, we have to do both groups this time. So let's look at early birds and we have night owls, okay? In both cases, if you go back in the question, once again, it says that they were randomly selected. 100 people of each of the two types were picked at random. So 100 picked at random. Same thing over here. 100 picked at random. All right, these samples need to be independent of the population. So assume more than 1,000 early birds. Ooh, it's an ugly bee. Good Lord, that's a very ugly bee. Hold on, I can fix this. And then same thing over here. Assume more than 1,000 night owls. And then as for normality, because this is a means question and our sample size is over 30, we can go central limit theorem. 100 is greater than 30, CLT applies. And same thing over here. So we're approximately normal. And the name of this is a 2 sample t-test for means. Cool. Assumptions and conditions. Phantoms. We named the test. All right. T-score. So it's the average of the night owls minus the average of the early birds minus population mean of the night owls minus population mean of the early birds divided by, all right. And once again, we always forget the standard deviation. That's cool. We go over to our formula sheet and we look at for two populations, okay? Go on over and then we see it is this guy right here, all right? So it's going to be the square root of, so it's the standard deviation of night owls squared over the number of night owls plus standard deviation of early birds squared over the number of early birds. All right. Go ahead and punch in our numbers. We know that this guy right here is 0, so we don't even need to put that down there. So I'm going to do 9.55 minus 7.26 divided by square root 5.88 squared over 100 plus 6.94 squared over 100. All right, for the heavier number crunching, we're just going to use our calculator here. So we go stat, test. This is a 2-sample t-test. We have statistics, okay? For X1, we're going to put the night owls in there. So that's 9.55. Standard deviation was 5.88, and our sample size is 100. Then for the early bird, 7.26, 6.94, and then 100 again. We're checking for mean 1 should be greater than mean 2. Pooled is no. Calculate. And we get a t-score of 2.51. P-value is 0.006. Don't forget to mention too somewhere, our degrees of freedom that we get off the calculator is 192.8. All right. And then we go ahead and write our conclusion. So our conclusion would look something like this. Based on our t-score of 2.52, 2.51, whatever, we are going to reject the null hypothesis. Remember, the reason why we're rejecting is that the p-value is much less than the alpha value, okay? If the average number of dreams night owls recalled were the same as the average number of dreams the early birds recall. So restating the null hypothesis in context, there is a 0.0063 chance of getting these results or more extreme, which is less than our alpha of 0.05. There is enough evidence to say that night owls recall more dreams than early birds on average. And once again, just to visualize really quickly what just happened with our t-score and everything like that. So this is not a part of the question. You don't need to do the answer, but just to kind of help you conceptualize it. So let's say we have our distribution right here, okay? So this is going to be the mean of night owls minus the mean of early birds. So it's assumed to be 0, right? What happened is that when we actually subtracted the two of them away, so if you do 9.55 minus 7.26, you got a difference of 2.24. So this right here represents what we actually got. Our p-value represents this area right here. And what happened is that, so this area right here is 0.006. 0.006. Remember, the further away our sample gets from the hypothesized value, the smaller and smaller and smaller the p-value is going to get. And since this area is so small, and by so small, I mean it's less than 5%, that's why we reject the null hypothesis.